Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 4 a.m. on Saturday in London. We're broadcasting live from Thousand Oaks, California. Thank you so much for joining us. Tonight's topic is dark energy explorers. We'll be back in 6.8 seconds. So tonight we were going to tell you about jellyfish galaxies, and then Jeff noticed that the whole project was actually complete for now. He checked again and found this Dark Energy Explorers project, which still has about 30% of the work left to do on it. So let's find out what Jeff learned about this new project.
Okay. This is, again, we're on Zooniverse. And what's that?
Go ahead.
Oh, okay.
Here's the link.
Yep. Oh, good. Yep, there's the link. And if you could put that in so it's clickable, put it in comments so it's clickable.
Yes.
So this is Dark Energy Explorers. And the main gist of it is that they're looking for galaxies that are 9 to 11 billion years old, because they're trying to find. Oh, hi Cliff.
Hi Cliff.
Hi Christina.
Hi Christina.
And Jared, I think.
Probably. That's cool.
But they're looking for galaxies that are 9 to 11 billion years old to see how they're moving, using their spectrographs to see how the galaxies are moving at different time periods in their, in the life of the universe. And 9 to 11 billion years old is basically, as it says here, when the universe was 2 to 3 billion years old. So,
well, I think it's important too to point out that distance and time are fairly related at this point.
Well, light year, yeah.
Because they're so far away, it's also that long ago. So.
Right. Yeah. And so they, as she mentioned, there's about 30% still available. Lots of work to do and has been done. And the whole purpose for finding the distant galaxies is because they want to measure dark energy and how dark energy affected the expansion back then. And they, I like this quote, with dark energy, we know nothing. It may not be dark and it may not be energy. It's the phrase we use to explain our ignorance. Basically, dark energy is just it's just a term that they're using to explain why the expansion isn't happening the way they expect it to.
I guess that's a good way to talk about something, is to have a term everybody understands as what this is. We don't know what it is, but this is what we're talking about.
Well, I think in astronomy, whenever you say dark anything, like dark matter, dark energy, it means they don't know what it is.
Oh, okay.
It's just a fiddly term that they add to the equations to make the equations match reality.
Oh, okay.
Which means that either there's something extra in the universe, like 90% of the universe that we can't see,
right,
or the equations are wrong.
Ah, okay.
And since they came up with the equations, they're trying to find that 90% of the universe that we can't see.
Right.
So.
Yeah, okay. I did talk about this a really long time ago, and when you commit to a talk, you got to go learn how to do it, what it is, and that's what I did. So basically, if they've taken all the things that they can see and quantify and added them all up, there's a whole lot more missing than we have, than we can see, that we know about.
Yep. Okay. So, and they're looking at the HEDEX map, which I'll go up to the about, and we'll show a little bit more about that. And this is again the Hobby Eberly Telescope Dark Energy Experiment. And they're looking for basically about right here, in the early expansion.
So when you say right here, it's the first stars right after the dark age, it looks like.
Yeah.
Because it's hard to see your cursor against.
Oh, it is?
Yeah.
Oh, okay. Looks okay on my screen.
Okay.
Now the head decks will produce a map by using a set of 150 spectrographs mounted on the Hobby Eberly telescope, a 10-meter telescope located at the McDonald Observatory in West Texas, known as VIRUS, which, okay, it was started in 2016, so it has nothing to do with COVID. But it's this nasty visible integral field replication unit spectrographs, which is a clunky thing that they came up with just to make the word virus.
Okay. But 150 of them, that's a lot.
Yeah. And the instrument is 95% complete, which means that they don't have all the spectrographs on there.
Mm-hmm.
But they're still taking measurements because they've got enough spectrographs to take some measurements. And so that's cool that we're getting early data off of them too. And at 95% complete, we're getting pretty good data. And they're looking at the fingerprints of atoms and molecules, and those are used to identify the atomic and molecular components of stars and planets. A shift in the position of the spectral lines tells the distance to the galaxy, so they can make a 3D map of the night sky.
Cool.
And, if you don't know, look up spectral shifting, and you'll see how they use spectrographs to find the distance of things. Basically, because the universe is expanding, the faster it's moving away from us, the farther away it is. And since they know the lines for, say, hydrogen,
right?
If they see those hydrogen lines somewhere else, they know it's shifted. It means it's either coming toward you or going away from you.
Right.
Yeah,
That's the red shift, blue shift, Doppler effect, the train that as it comes closer, it's compressed, and as it goes farther, it goes. So it's, whoa, it moves past you. And you hear the difference. That's the same effect in light.
Yep. And so, so they're looking for really, really small blips, and they're looking for the distant galaxies. And when we go up into the classify, actually, here's a field guide. They're looking for the distant galaxies, and this is how they look. And we'll see bigger pictures. This is a small one. But they're looking for things that are really, really small, where you barely see anything in this square here, or especially in here. If they're looking for small dots, and they're looking for sharp peaks that are relatively on point here.
Because if they're bigger, they're closer, right?
Right, yeah, and here's a nearby galaxy, and if you notice, they're huge dots.
Yeah, that's a lot bigger.
And also, sometimes it looks the same, sometimes it doesn't on the spectrograph here. But they're just huge dots, and if any of these are in their data set, it messes them up. So they're looking to exclude anything with a nearby galaxy in it. So then we go on to the classify, and the tutorial is basically just that. What they're trying to do is, they're looking for data that matches the spectrograph line that's at the bottom of the image. But they don't exclude that. The only thing they want to exclude are the nearby galaxies.
Okay.
So even if it's messy data, they want to keep going on it. And this is just showing how these show different spectra where, of the star. But it almost doesn't matter what these are, because As long as it's not a nearby galaxy, they want it. So if it's a distant galaxy or nothing, so even if it's just noise that caused them to take this shot, or to include this shot in here, they still want you to click on it because they just want to exclude nearby.
Okay. We got a comment from Cliff.
Oh.
So Cliff met Brian Schmidt. Oh, great. Oh, cool. For dark. Okay.
Yeah, an Aussie Nobel Prize winner.
Setting Springs was mapping the 6-degree field of view. The first picture you showed. Oh, no kidding.
Huh.
Wow, that's very cool. Thanks for letting us know, Cliff.
Yeah.
That's very cool to meet a Nobel Prize winner, too. I like that. Good on you, mate.
Yeah, so basically, if it's a small galaxy or nothing in there, they say swipe right because they've got a mobile app also.
Oh, I see.
But there's also a button here for distant galaxy or nothing. So, like they said, the only time that you want to press anything other than distant galaxy or nothing is if it's nearby. So all of this tutorial just basically reiterates that.
Still, process of elimination is a good way to do science too. You get rid of the things that aren't part of your data set, basically.
Yep.
Yeah, that's good. So it's a real service that people can provide to this particular project, Dark Energy Explorers.
Right, yeah, because they need a clean data set.
All right.
And that's, so this is actual classification.
Well, and before you do that, we like to talk about how people are better at seeing these things than, say, their little computer-generated AIs or, an algorithm. You know, human mind is actually more sensitive to different things that they're looking for.
Is that here? No. There was someplace. Here it is. Thanks for all the work, because here's an example of how people do better than their than the algorithms, because the algorithm said that this was a nearby or a distant galaxy, but all of the data is overwashed by this here, and people can spot that this little dot here isn't where the data is coming from. And if you notice, this is really messy here. And so even though the algorithm said that this was a distant galaxy, it's actually a nearby galaxy.
Okay.
So you want to look at all of this. Is there anything there? Is there something nearby that's messing things up?
Got it.
And so, and here's a neat one. Oh, this is really tiny on the screen. But black holes, they've actually spotted some black holes in here. Now, I haven't in all of my going through it, but it's probably pretty rare. And you probably want to hit talk on that and let people know that you spotted one, because even though they don't want it for this study, someone might want to know where those are.
Oh, okay.
But they show up as an oval rather than a dot, and it's a much broader spectral line, spectral range here.
Yeah, it's not a tight.
Yeah, it's not
a narrow peak. High peak. It's
it's a hump.
Okay, cool.
Yeah. So then we get into classify, and here we go. Data's all over the place, and you've got this nearby galaxy here.
Yep.
So it's nearby galaxy or star.
Oh, and you're live. You're actually doing this particular.
Yeah, because all of the ones that I did and I marked. We're trying something new here. I'm trying just straight on the website rather than having screenshots and marking them up and stuff like that. So yeah, this is all done live here. So last time it took me nine images to find one with a nearby galaxy to give it as an example. And here, first thing we come up with is a nearby galaxy.
Oh, very cool.
So done. Again, very obviously nearby galaxy right there.
It's just so huge.
Right. Yeah.
And also your chart of the bottom, right?
Yeah.
That helps you determine.
Yeah.
That it's a nearby galaxy, because there's so many data points in the flat part right there, right?
Yeah. It's not that there's so many. It's just that they don't follow the curve well.
Oh, okay. I see.
And they follow it okay. But the fact that this thing is big, it's bigger than these small circles, and and eventually we'll get to a distant galaxy and you'll see the difference. There we go.
Oh, cool.
There's a distant galaxy. If you notice, there's pretty much nothing in the shot. Here's what they're getting. Now it is all over the place, which means that it probably isn't a distant galaxy. It's probably nothing there. We're probably just seeing random stuff, and they put the blip up here because there just happened to be random noise at the spectra that they're looking for.
Ah, okay.
That's my guess. But
so here's where the person comes in that can really tell the difference,
right.
Not just it looks
and
like.
In this case, it doesn't matter that it's random noise because distant galaxy or nothing.
Or nothing. Okay.
Because all we're doing is excluding nearby stuff.
Right.
So we hit nothing. And if you had a question or you found something that you wanted to do, you could do done and talk, which would get you to a screen where you can post to the group about it.
Yeah, sounds very similar to the one I did before.
Yeah,
with Star Nodes. Yeah,
it's a Zooniverse.
Okay. Yeah.
Standard. And so here we go. This looks like a nearby galaxy just from looking at this and here. And if you notice, this is all over the place. Even though there's a peak here, it's all over the place, and there's a big galaxy right there.
Right.
This is totally the opposite of when I did it. And okay, here's again probably nothing there. Look at the spectra; it just is all over the place. But it's not a nearby galaxy, so we click there, and that's.
So this is the work. This is the actual work that you're doing. And what they're trying to do, there's lots of theories surrounding what, in fact, dark energy is.
Yeah.
And you were telling me before, they're just trying to...
exclude nearby stuff, yeah.
Well, no, they're trying to eliminate competing theories.
Oh, yes.
This is the part I read.
Oh, yes. Yeah, I skipped that because I didn't have my slides set up. I was just tooling through the website. The main thing is that there's so many theories about what exactly dark energy is.
Right.
Is that by looking at the movements of all of the galaxies of different eras. Oh, you might as well show us.
Oh, sure.
By measuring the movements of galaxies of different eras, they can see the changes in the rate of expansion.
Okay.
And that will let them eliminate various dark energy theories.
Okay.
And that's...
Yeah, so if the actual empirical data doesn't fit the theory, then the theory has been proven wrong.
Right. And
that's
so...
how science works.
Yep. And they've probably got a theory for every type of movement that you can find in there. They just need to eliminate the ones that don't match. Right.
Okay. So did you have anything more to share on the website?
No, that's it that I can remember from the slides. We found it all.
What's that? Dags? What?
Yeah, I think that's an Australian term there, mate.
We don't know what that means. But thanks for sharing. Anyway, so yeah, so this looks very easy to do. It doesn't look like you have to register. You can just go and do some work, and maybe that's all you do. Maybe you go back and you do a little more. But, not a lot to figure out. Some of these are very complicated. You have to register, you have to apply and all that stuff. But this one just, go in and help. Yeah.
It's nowhere near like the AI training for the Mars rover.
Right. Yeah. That was pretty involved.
Yeah.
And you had to register for that too, didn't you?
Yes.
Okay.
Yeah. You had to register and pass a tutorial, all of that stuff. Yeah.
Okay. Still don't know what DAGS is. So come on, Cliff. You got to tell us. Give us something. Alrighty, so at this part of the show, we generally like to talk to you about what's in the night sky this week. That covers looking silly. Okay, I see. He did tell us. Here it is. Looking silly. Yes.
Me?
We're good at that.
Me?
So that's going to cover between June 18th and June 25th. Today the moon is 8 days old, just past first quarter moon. The full moon is on the 24th. I'll talk about that some more in a minute. The 20th is Father's Day. Wish your father a happy Father's Day. The solstice is on the 21st. And of course, in the Northern Hemisphere, we get into our summer season. And in the Southern Hemisphere, they get into their winter season.
Well, I think they still call it summer. It's just cold there.
I don't think they call it summer. But Cliff can tell us. He's in Australia. On June the 23rd, Mars crosses the Beehive Cluster, which is also known as M44. You can look for that in the early evening. It's kind of heading west and setting before midnight. June the 24th is the full strawberry moon, and it's another supermoon.
Of course, because hey, half the moons have to be supermoons, right?
Well, it's an orbit.
They get their participation badge that way.
Oh, I see. It's just the orbit. So the moon orbits just a little slightly closer sometimes and a little farther away sometimes. And if you happen to see a full moon when it's also close, that's what we're calling a supermoon these days. Mm-hmm. You're up.
Okay. If you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. And join us again next Friday, June 25th. We'll be continuing our citizen science series with Gravity Spy, a new project on the Zooniverse. And here's their description of the project. Help scientists at LIGO search for gravitational waves, the elusive ripples of space-time.
I am looking forward to learning more. And that's, if you recall, LIGO was they were looking and then it went whoop. So it's actually got a visual and a little bit of a sound too. All right, so Cliff is telling us not too cold. 20 degrees, 5 at night. And that's centigrade for people in the United States.
Yep.
All righty. And I am working on bringing in some more guests. We're actually in talks with 3 different people. One is Sarah Treadwell. We're looking at July 23rd for her. Valerie Stimac-Bailey is also someone we're in talks with. Grant Blaisdell, and I'll tell you a little bit about Sarah Treadwell. Has all kinds of things going on. Valerie wrote Dark Skies, a practical guide to astrotourism. It's a Lonely Planet publication. And Grant can tell us how to invest in space businesses. So if you have any questions for us, if you want to be a guest, let us know. We would love to share our live with you. Other than that, unless you have something else?
No.
Have a great week, people.
Yep.
Thanks so much for joining us. We really appreciate you being here. Good night.
Good night.